Are you people able to read this question? I'm showing the screen. Some of you have to respond to me. Priyadashini, are you able to read this question?
Yes, sir.
Okay. So please, okay, I'll just read for you people once again. In fact, you can see the question on the screen. That let E1 function of R, E2 function of R, and E3 function of R be the respective electric fields at a distance R from a point charge Q. That means this electric field E1R is the electric field at R distance due to point charge Q. And this E2R, this is due to an infinitely long charge, an infinitely long wire with constant linear charge density lambda, and E3R with the electric field at distance R due to an infinite plane with uniform surface charge density sigma. Now, if all these electric fields at certain distance R0 are equal, okay, then which of these four options will be the correct answer? Which of these four options will be the correct answer? You have to answer this question. Okay, there are four options. Among four options, which one will be the correct answer? So this is a question which was asked in JEE Advanced 2014. Okay, this is a question from competitive exam, but not very tough. Don't think that it is JEE Advanced is very advanced question. No, it is not very advanced question. Uh, then try to give some idea how do we solve that. Okay, it is kind of a discussion class today. So Nikhil, what do we do? First, what do we do to solve this problem? What will be your first approach? Actually, that is important. First approach is important to solve any question in a competitive exam. So what you would like to do? Nikhil, Kirtana, who would like to answer this? Any idea what we should do? Okay, then I'll give you the idea and then try. I'll just give you another 2 minutes, okay, to tell what you would like to do. Okay, okay, so Soma had answered. She could not understand. Okay, I cannot understand, sir. Okay, so Soma, can you tell me whether you understood, you could not understand the question, or you could not understand my question, what I am asking you? You can write in the chat box. Nikhil, okay. So Soma is saying that she could not understand the question itself. Okay, fine. So anybody else could not understand the question? Then I'll read it, or I'll tell you again. Kirtana also did not say. Okay, she also could not understand. What about Nikhil and Priyadarshini? Please answer. You can write in your chat box whether you could understand or not. Okay, I'll read out the question again. See, there are three electric fields given here: E1R, E2R, and E3R at a distance R, and these electric fields are, see, E1R is due to a point charge which is having charge capital Q. E2 is the electric field at a distance R. It is due to a line charge, long, like infinitely long line charge. Okay. And E3 is the electric field at a distance R due to infinite plane sheet with uniform surface charge density sigma. Okay. Okay. If I draw, maybe you can understand. Okay. So the first question we are, so see this E1, the electric field at a distance R due to what? Due to point charge. Point charge Q. So let us see what is the expression for that first. Let us see what is the expression for that. So at a distance for a point charge, what will be the electric field? This much. So the second one was the electric field at R due to a long wire. In fact, this is infinitely long. Infinitely long wire having linear charge density. Lambda. So how do I write the expression for that? Actually, this is important. What you have to do, so for any competitive exam, you cannot do all the derivations like since beginning. What you should do, you should remember. You should remember the expression for the electric field due to a long, infinitely long wire having charge density, linear charge density lambda. You should remember what is the expression for electric field due to a point charge. So those things you should remember. If you don't remember now, you try to remember. Today I am writing for you. So this will be, suppose this is a long wire. I am just calculating electric field over here at r distance. Okay, it has charge density lambda. So what will be the electric field? It is actually lambda by 2 pi epsilon naught r. Okay, if somebody remembers, it is very good. If not, you have to remember this expression. Okay, you have to remember, or otherwise quickly you have to like derive this expression, but that will take like long time, and in the competitive exam you will not get that much time. Okay. Okay, so this is, so I'll just clean them and then I'll write in a small space u1 r, then we have got q by 4 pi epsilon naught r square. Then e2 we have got, this is for infinitely long wire, so that is lambda by 2 pi epsilon naught into r. Excuse me. So the third one was actually electric field at r okay. uh okay, let me see who has asked this question. Okay, so Soma, we are asking this question. I think, yeah, I'll answer this. Let me answer this question, then we'll answer your question, how do you get 2 pi. Okay, and this is, see, I'm not writing from anywhere, I'm writing from your book itself, textbook itself. Okay, yeah, I'll answer you. Now first let me uh, solve this problem. Okay, so this is due to plane So infinite plane which has charge density, uniform charge density. They have said uniform surface charge density, density sigma. Okay. So for this, I have taught. Actually, I have already covered this in my theory classes. I think this is your first class, so that's why you may not be. If you have read, then you could understand. But if you have not yet started your 12th standard study, then it will be difficult to understand. So I'll just write the expression for the electric field. I think Priyadarshini or Nikhil can tell what is the expression for the electric field for an infinite plane. I'm just drawing a part of infinite plane, so it can go up to this. Okay, infinite plane means, you know, like you have two dimension. Infinite plane means two dimension. So you have two infinite direction, and other direction will be actually limited. Okay, so this is your infinite plane, kind of that. Okay, so this, suppose this is z and this is y. So this y z plane, y and z direction can go up to infinity, but this x direction will be limited. So this is called infinite plane. Okay, this is infinite plane. So due to infinite plane which has charge density sigma, what will be the electric field? Electric field at any distance, what will be the electric field? Suppose r distance. It does not depend on, it does not depend on the distance. Okay, it depends only on this. This is the expression for the electric field due to infinite plane. Okay, charge plane. So sigma is the charge density on this. Okay, and since they have told positive, I have taken positive. So this is the expression for E3. E3 is the electric field created by an infinite plane having uniform surface charge density sigma at r distance. It does not depend on distance. Electric field due to this infinite plane does not depend on distance. So this is the expression for E3. I'll just clean this part, and I'll just write in a compact space so that I can complete this solution in this slide itself. So I'll just write this expression again just beside them. Okay, so look, now I have expression for this also. Soma, if you have any doubt in this, I'll clear you after some time. Let me. So these are actually questions from JEE Advanced and all those things. So if I like derive everything, it will take maybe 1 hour for one question itself. So what we should do? We should remember the expression for the electric field for various geometry. Okay, various charge distribution. So that you should have already done in your by your own. So to solve such kind of problem. So now look the question. The question says that at certain distance, if these electric fields are all same, at certain distance, if the all electric fields are same, then what of this, like which one of these four options will be correct? We'll take up this condition. Okay, we'll take this condition first. We'll take this condition that E1 R0 is equal to E2 R0 is equal to E3 R0. Okay, so E1 R0 means what? I get Q by 4 pi epsilon naught R0 square. This equals to lambda by 2 pi epsilon naught. This is a very simple problem actually. If you remember the expression for the electric fields, then thereafter it is very simple. See, this is sigma by 2 epsilon naught. So this condition we have got. So let us see what are the options. What are the options? So first option says Q. What is the value of Q? Here they have given 4 pi sigma into r square, r naught square. Let us see whether this is correct. So we'll try to find out electric field in terms of sigma, Q in terms of sigma. Since the first option has been given, see Q, capital Q, the value of Q in terms of sigma and R0. We'll try to find out from our condition, given condition, what is the, so this is, these two, so what I can write, Q is equal to, so 4 pi sigma R naught square, sigma also will be there, divided by 2 epsilon. So this epsilon goes, okay, and this 2 goes. So what we get is actually 2 pi sigma r naught square. It is not 4 pi. Okay, it is given 4 pi sigma r naught square. But what we get? We get 2 pi sigma r naught square. So the first option is not correct. So first option is not correct. So this is not correct. Let us see this one, whether this is correct. That means you have to find out the value of R0 in terms of lambda and sigma. Let us see whether that is correct. So one by one I'll see. So this part I'll just remove because first option was not correct. We'll go with the second option and then check whether we get. So I think you people now can do by yourself. But since time is less, I'll just solve for you and you can see whether it is going all right. So I'll just take these two. So then what I get, I have to find out R0, right? So look here, lambda by 2 pi epsilon naught, okay, into R0 is equal to this sigma by 2 epsilon naught. So 2 epsilon naught I'll just write out from here, okay. So what I get from here then, R naught is equal to lambda divided by pi into sigma. Let us see what is R0 given here. So here it is given lambda by 2 pi sigma. So but what we get is actually pi sigma, not 2 pi, not 2 pi sigma, okay. So that means the second option is also not correct, okay. Now let us go with the third option. So what is the third option? Third option says when E1 R0 by 2, then the value of this will be equal to 2 into E2 R0 by 2. Okay, let me explain you what does this mean. So now this condition I will not keep here, okay. I have already written what is E1, what is E2, E3, etc. Now look, I'll write E1 R0 by 2. What is that? This is actually, see, I'll just put here R0 by 2. In place of R, I'll put R0 by 2. What I get is this 4 pi epsilon naught R0 by 2 whole square. It will be 4Q by 4 pi epsilon naught R0 by 2. Sorry, R0 square. Okay, R0 square. So this is nothing but 4 into E1 R0. If I simply put R0, then this is the electric field due to R0, like at R0, okay, at R0. So this is actually 4 into ER0, okay. Now look, if I find out the other one, E2 into R0 by 2, sorry, E2 R0 by 2, E2, this is the E2, I have to find out R0 by 2, E2 R0 by 2. So I'll just put similarly here, instead of R, I'll put R0 by 2, so 2 will go up, this will be 2 pi epsilon not R0. So what does this mean? This means E2 into E2, yeah, E2 R0, okay, 2 into E2 R0, okay. So this is the thing we have got. Now look, my Because see this again, this option says whether 2 into E2 R0 by 2 will be equal to ER E1 R0 by 2. Whether this option is possible. So that means I have to find out a relation. See, I have to find out a relation between ER0 by 2 with E2 R0 by 2. I have to find out a relation between them. So these are the options. So I have to find out a relation between ER0 by 2 and E2 E1 R0 by 2, E2 R0 by 2. Let us see whether we can find it out. So as I said, E1 R0 by 2 R0 by 2 is actually 4 E1 R0. Again, E2, I'll just write the expression for E2 R0 by 2. E2 means lambda. It was 2 lambda 2 pi epsilon naught R0. This was the expression. Now see, if I want to find out the relation between these two, or E1, I'll write here E1 R0, that is actually Q by 4 pi epsilon naught R square. Okay. So if I want to find out a relation between these two, I have to find out a relation between this lambda and Q. Okay. So how do you get that? Lambda and Q. We'll get it. See, we have expression for this. Actually, there was a condition given. What was that condition? The condition was given this E1 R0 is equal to E2 R0 is equal to E3 R0. This condition was given. So I'll just take this condition to find out what is the value of lambda. Okay, find out what is the value of lambda. So this is Q by 4 pi epsilon naught R0 square, and this is lambda by 2 pi epsilon naught R0. Okay, R0 1 R0 goes, 2 pi goes with 4 pi S2, like this epsilon goes. Okay, what is the value of lambda then? So what does this lambda imply? Lambda is actually Q by 2R. Q by 2R. Okay. So if I just put this value over here, see here, what I get. Let us see what we get. If we have to have a relationship or comparison, then we must be having these two in terms of Q or in terms of lambda. It is easy to find out lambda. So I'm just replacing lambda with this Q by 2R. 2R0 here, 2R0. So I'll just write it. This 2Q, already 2 was there. So I'm just replacing the value of lambda 2 pi R0, and here see there was uh, okay, yeah, Q by, actually this is Q by 2 R0, 2 R0. Okay, so what we get, 2 into Q into so divided by 4 pi epsilon naught R0 square. Look, now we will get a relationship between these two. Okay, we'll get a relationship between these two. So let us see what is the relationship. E1 R0 by 2. See, this is the value. So can you tell me? So this, now I'll just clean all of them, this intermediate steps, and okay, I'll write these two side by side, and you can tell by yourself what is the relation between these two guys. Okay, now tell me what is the relation between these two. E1 R0 by 2 and E2 R0 by 2. What is the relation? So if I just multiply 2, you'll get the same answer, right? So 4q by 4 pi epsilon naught r0 square. You will get, if I multiply 2, that means what? E1 is actually, so this will be nothing but see, this E1, you will get E1 R0 by 2, you will get by multiplying this with E R0 by 2. Okay? Do you understand this? So this is the option which seems to be correct. You just see in your question. See here the question. See, C is actually E1 R0 by 2 is equal to 2 into E2 R0 by 2. Okay? This seems to be correct. And if you look here, the last option, this is actually correct. We have got the correct option. Let us see whether this is again correct. E2 R0 by 2, we have already got. Whether this is equal to 4 E3. This is certainly not, because there is no R dependence in R3. Sorry, E3. So this D will not be a correct option. So C is the correct option. Okay. So this is the correct option we have got. So is there any question or any doubt? I think Priyadarshini, sorry, Soumya had asked me a question that I'll answer. But before that, in solving this question, whether you have any doubt? Do you people have any doubt? You can write to me. If you are not able to speak, you can write to me. Okay, nice. Soumya has written. Nikhil and Priyadarshini, do you understand? I think you could understand this because I had taught you the theory part of it. So you must be
Yes,
understanding
sir.
this. Okay. What about Nikhil? Nikhil, do you understand this? No, Nikhil, I could not hear you. Anyway, Kirtana, what about Kirtana? You are not speaking anything. So this you have understood, right? Okay. Hope you have understood. You can write to me. Okay, you can write to me in the chat box. All right. Uh, hope everybody have okay. Okay. So I'll just now answer Soumya's question. See, Soumya, we had already covered this theory part. Uh, so this is there is a theory actually theory part. I'll just let you know what it is. Just a minute. Okay, so that is due to, so electric field. How do you get electric field? Electric field due to electric field at any r distance due to a wire, long charged wire. Obviously, this charge is actually uniformly charged and it has uniform line charge density, charge density lambda. Okay, so look in your textbook, you will see. In fact, I'll also show you. So if I think that this has uniform positive charge density lambda, and this is infinitely long, it can go infinity in both sides. Okay, so by the symmetry, like there are always physics goes with symmetry. There are cylindrical symmetry, Okay, there will be sometimes spherical symmetry with the object, spherical symmetry. Sometimes there will be a planar symmetry. So these are symmetries. Okay. So in this case, when you have been given line charge density, see, I can see this is my long wire. What I can do, I can actually just just rotate, or I can just run around this in a circular path, and I can move, right? I can move in this way also. Okay, I can do this, right? So what is the symmetry I get? I get a cylindrical symmetry. So for a line charge density, you get cylindrical symmetry. Okay, and by in the cylindrical symmetry, we have shown, even in fact in your textbook also it is given. You can read it, that the electric field always act, or always it is radially outward. Okay, radially outward. Electric fields will be always radially outward. So this is actually in the Gauss's law part, Gauss's law. This part you can see. Okay, so you understood how we got cylindrical symmetry for this particular geometry or linear charge density. If you have a point here P, you rotate with a C. Suppose I have to calculate electric field at a distance R. You just take a radius of R and just go in a circular path around it, and then you have to cover the whole charge density to calculate the electric field at this point, isn't it? So you have to cover. So you have to go, like you have to go along the direction of the current also. Sorry, this line charge also, right? So if you go like that, so what does it mean? So suppose I have a circle like this, I have another circle like this, I have another circle like this. Okay, so if you just join all of them, what you get? You get a cylinder. So this is how for a line charge density you get cylindrical symmetry. When you have cylindrical symmetry, by symmetry, even for spherical symmetry also, electric field will be always acting radially outward. So in this case also electric field is not along this direction, and I have taught already, I have taught why it should not be in this direction. Okay, why it should not be along the uh, direction of this. Okay, that is also written in your book. Okay, I'm not going to that detail. You have to read it. You have to go back and read. Okay, still if you don't understand, then I can I think I can answer you in some special class. Okay, so when electric field, see Gauss's law, I'll be calculating electric field using Gauss's law. So Gauss's law says that E dot ds, okay, E dot ds, these are vector, E is the electric field, okay, and ds is this vector is the area vector, and this is equal to charge enclosed. So if I say Q enclosed divided by epsilon naught, this is according to Gauss's law. This is according to Gauss's law. So whenever we have to apply Gauss's law to calculate electric field for any geometry or any charge distribution, we have to first draw a closed surface, Gaussian surface. Okay, so which I have drawn here as cylinder. See, I have to calculate electric field at r distance. So what I have to do, I have to draw a cylinder having a radius of the circular uh, portion as that particular distance r. Okay, and suppose this has a length l. Okay, this has a length l. Okay, so you might be thinking, sir, it is infinitely long, but you have taken this much only, this much l cylindrical Gaussian surface. I'll show you that length does not matter here. Okay, length does not matter. You might be thinking, sir, how it is. Okay, I'll just clean all these things because this become very hazy. I'll just draw it here again for you. this is okay, this is r distance. So my electric field is along this way. So the Gauss's law says it is E dot ds. This is the total flux through the Gaussian surface will be equal to the charge enclosed by epsilon naught free space permittivity. So now if I find out this E dot ds or the flux through this cylindrical surface, as I said, electric field is always in this direction, okay, radially outward. And this is what? This is the area. So see, the electric field through this is zero. Electric field through this is zero. Like flux through this will be zero, because electric field and the radius vector will be perpendicular to each other here. So if I calculate flux through this, so electric field is not there in this direction, right? So flux will be zero in this flat surfaces. So flux will be only there for the curved surface. So I have electric fields for only for the curved surface. Okay, electric flux through the curved surface. So what does this mean? This means electric field. And see, I have to check the direction also, right? Because this is E ds cos of theta. Cos of theta. What is the theta? Theta is the angle between this electric field and ds is the area vector. So area vector is always, suppose I have a plane like this. So this area, this will be having area vector always, like area. This is actually outward normal. It is denoted by n cap always. Okay, if I have a surface, flat surface like this, so it will be having its direction. So if this has area ds, so it has direction outward normal. Okay, if you just see the bottom part, then also it will be outward. Okay, outward. Okay, this will be n cap. Outward normal will be the direction for the area. So see, for a curved surface, this curved surface, the direction is along this direction itself. Okay, so area also is in this direction, electric field also in this direction. So theta is 0. So what you get here? So theta is 0. That means I can, an electric field is constant within this radius. Everywhere you go this way, you go this way. Wherever you go, electric field actually constant over this curved surface. If you take a bigger radius curved surface, then electric field will be having different value, but that also will be a constant value. If that is E2 and this is E1, E2 will be constant over the surface, curved surface. So I can take this electric field out of integration. I can just take integration of the area, and I have to find out charge enclosed also divided by epsilon naught. So this is actually for a cylinder. What is the area of the curved surface? This is 2 pi r into L. This is my area of the curved surface. And what is the charge enclosed? Charge enclosed will be charge, see, line charge density lambda into the length of the cylindrical Gaussian surface. So what I have taken, that I have taken L length. So lambda into L by epsilon naught. Now L goes up from both sides. And what is the electric field expression for the electric field I get? Lambda divided by 2 pi epsilon naught r. So this is the expression we get for electric field for an infinitely long charge distribution. Okay, I think Soma will be satisfied with this. If not, kindly just go through your book. I'll show you the topic here where you have to go and read. I'll show you that. See, Soma, it is actually here. You have to read this topic, okay? So field due to an infinitely long straight uniformly charged wire. So this is the portion. If you read, you can find out how to calculate the electric field for a long charged wire, and what will be the actual expression for that. And the electric field will be always radially outward. Outward direction. Okay. In fact, this is for positive charge. It will be radially inward also if you uh, have charge density negative. Okay. if you have negative lambda. Okay, I think I have taken a lot of time in this first one. I'll just quickly give you another question. Okay, so we'll just quickly solve another question. Let us do that. This is the second question. I hope you will be able to solve this question. Read this. If you don't understand, tell me. I'll give you exactly 2 minutes from now. Please read this question. Okay, I have got your option. Okay, who is that? I think Kirtana has answered for that. Okay, yeah, Kirtana, I'll just okay, nice. Nikhil also has answered. Very nice. It is yeah, it is inspiring for me that you people are answering this question. Nice. So anything, any, I think Priyadarshini Somya, you can also answer. Very good, Nikhil. I am happy with you. Even I am happy with Kirtana also. You have answered. What about Priyadarshini? Okay, Shoma also said first option. See, there can be multiple answer. Okay, I should mention this. There can be multiple answer. There can be multiple answer. I'll just give you 2 minutes more to think whether you have answered correct. See, I am telling you that there can be multiple answers. Okay, more than one option can be correct. So now just think with your options, and if you think like another option also will be correct, you can just add that. Kirtana, Nikhil, and Somya, all of them. Even Priyadarshini also can answer again. Okay, Sauravi also had answered. Okay, first option. Okay, B and C. Who is that? Kirtana. Okay, nice. Kirtana, you have changed your option. I think you first you said third, and now you are saying B and C. Okay, so fine. Hmm. Priyadarshini, I have not heard anything from you.
Sir, understood, sir.
Okay, no, this question, I have given you a new question. So, can you answer this? That's what I'm asking.
Trying, sir.
Okay, sorry, which one? Which which one is the answer?
I'm trying to answer for this question, sir.
Okay, fine. You can try. So yeah. Yeah, since Priyadarshini is trying, I'll just give her another 1 minute, maybe 1 or 2 minutes. This is also a
Sir,
question
yes,
from
sir.
competitive exam. A is correct. You are saying A, Priyadarshini?
Yes,
Only
sir.
that is the option correct. Okay, anyway. Okay, so you people have answered partly, but if since it is a competitive exam and if there are multiple answers correct, then you have to answer multiple whatever questions are there, like whatever options are correct, you should answer that. So see, somebody had told B and C, that is wrong. Only C was correct among these two. Okay, somebody has told one. This is correct option, but another option is also correct, that is C. Okay, so A and C will be the correct options. Okay, I'll tell you how. When I have a solid sphere, what is the electric field at any point inside? Okay, this is small r, suppose, and suppose this is your capital R, that is the radius. Okay, what is the expression for the electric field? Okay, if you don't remember, since it is a solid sphere, it has a charge density. Okay, all over the space you have charge. Okay, so you can quickly solve it. Actually, you see, I know left hand side flux will be E by 4 E 4 pi r square, and you have to find out charge enclosed and by epsilon naught. Okay, so charge enclosed is the main part here. Look, in this case, charge enclosed, see this part. So charge enclosed you have to find out for the, see, part, this part alone. Now you are thinking this is another sphere, small sphere of radius small r. So what is the charge enclosed by that? Okay, so look, if this is rho q by 4 pi epsilon naught, sorry, 4 by 3, this is charge, volume charge density, 4 by 3, 4 pi by 3 into r cube. This is the r cube. This is rho. What is the volume for this particular portion? This is again 4 by 3 pi small r cube, right? So you just put this is the q enclosed. Okay, this is q enclosed. You put it here, what you get? I think everybody has answered that. This was here from this 4 pi. Okay, so this will go off. This is q into r cube by this is r cube, and see left hand side there was this one. So this I'll multiply here 4 pi r square. Okay, 4 pi r square. See, look, this r square goes with r cube, so 1 r will be there. So what you get is this one, 4 pi r cube. So this constant term, and this is the r. So it varies. See, it varies linearly inside. Okay, up to capital R. So this is correct. All of you have told that. But what about outside? What about outside? See, outside, see, for a sphere or any spherical cell or whatever, the charge will be as if the point charge, the whole charge, as if it will be concentrated at the center. You have q charge at the center, and you are calculating electric field outside point r at r distance. So for a point charge, how do you calculate? So that is q by 4 pi epsilon naught r square. So for a outside point, when you calculate electric field, you have to think that all the charge, as if all the charge if this is Q given, all the charge is concentrated at a point. Okay, exactly at the center. It is concentrated. The whole charge concentrated as a point charge at the center. So you see your electric field outside. That means when your this is this up to infinity, in this range, your electric field will be actually proportional to 1 by r square. Understand? So inside, so if I draw this electric field, this is electric field, and this is, say, this is the distance r. So up to the radius or up to the surface, electric field will be actually proportional to r. It will be increasing with respect to r, okay, and it will be decreasing after the radius. See, when r is greater than your radius, then it is actually varying as 1 by r square. It will be falling like this. Okay, this will be like this. So it is proportional to 1 by r square. So there are two options correct. You look here. So this option, so this is decreases as r increases for this range. Okay, okay, understand, right? So this is not correct because this is the whole range. It is not decreasing, and this is not discontinuous at r. It is not discontinuous. Look here. This is a continuous thing. Okay, this is not discontinuous. Here it is not a discontinuity. Okay, it is not a discontinuity. Understand? This is small r is equal to r. This is not a discontinuous thing here. This continuous in fact. Okay, this is how electric field vary. Okay, so A and C both were correct. All of you answered A. That is very nice. And C, I think Kirtana said C, but she just overlooked this one. So both are actually correct. A and C. Okay, so if I take another 10 minutes, will you mind just to solve one more problem? What do you say? Write in the chat box. No problem, Shoma said. What about Priyadarshini, Nikhil, Kirtana?
Sir, I have a doubt, sir.
Okay, Nick. Okay,
Sir?
okay. So who is this? Kirtana.
Kirtana.
Okay, Kirtana. Yes, yes.
Sir,
What was your doubt?
How a non-conducting sphere will spread uniformly charge?
How a non-conducting sphere?
How a non-conducting sphere will spread charges uniformly?
Okay, this is your question.
Yes, sir.
Okay. Okay, for a non-conducting sphere, how the charge will be spreaded uniformly?
Yes, sir.
Actually, your doubt is very genuine. For a conducting sphere, we have learned, but how
Yes.
a non-conducting solid sphere? Okay. Uh, See why it is said non-conducting. You know, if it is conducting sphere, okay, a conductor, what will happen? You know,
The charges
what
will
will
be
happen?
spread all over.
Only no, not all over, only on the surfaces.
Oh, yes, sir.
In a conductor, do you understand that?
Yes, sir.
We don't have charge in okay. So I think that's why they have just mentioned this non-conducting solid sphere. Otherwise, all the charges will be on the surface. For a conductor, all the surface resides, like all the charge resides on the surface. Okay.
Yes.
In the second chapter, there are 5 points about conductors, 5 or 6 points. which I have discussed already in the. I think you have also read. I hope in the second chapter. Have you started reading or have you read the second chapter already?
No, sir, I'm currently in first chapter only.
Sorry.
So now I'm reading. I'm in currently first chapter, sir. I have not read first chapter.
Okay, fine. But still,
I
you could.
missed your
Okay, you attempted to answer. Okay, yeah, I know, yeah. So you have attended two. I think so far two maybe two lectures, one or two
yes, sir.
lectures. How many lectures have you? Okay, fine.
Two.
So Kirtana, you have to read. Actually, there are six, almost six properties of conductor. So for a conductor, all the charges resides on the like on the surface. Okay.
Sir.
So that's why they have
Okay.
mentioned on non-conducting part. Okay. And this is a question from J like IIT JEE, so it is not like a vague word or maybe incorrect word. It is not an incorrect word. Okay, fine.
Okay.
So anyone else has any doubt? Yeah, anyone else has any doubt? Okay, then I'll just take up one more problem. So that this problem will be very simple. Okay, this will be simple. I'll ask you to first write down, like answer this question. Okay, then I'll solve that. Okay, if you can't. This is in fact from your book itself. Okay, so NCERT book itself. Okay, uh, suppose you have a point charge. I'll just suppose you have a point charge Q. Okay, uh, d by 2 distance directly above the center of a square of side D. So I have a square of side D. So all of them are D. Okay, square of side D, and I have a point charge Q. Okay, Q directly above here. It is okay, directly above. What is the distance from the surface of this square? The distance is actually d by 2. Okay, this charge is residing just directly above the surface and d by 2 distance, okay, from the surface. Then you have to find out the flux, electric flux. Okay, electric flux. Uh, Obtain the expression for the electric flux through the square. Through this square, what will be the electric flux? I think all of you can do this quickly. Do it and then tell me. I'll give you 2-3 minutes. Then I'll start discussion again. Kirtana, on next class again, I'll tell you what is the difference. So I have just told you that why non-conducting word has been taken, but I can tell you again in detail what will be the difference if I again tell conducting sphere. In fact, all of you can think if there was a conducting sphere, what would have been happening for this question, the
Okay.
same question.
Sir, I
Okay,
have another
yeah.
doubt. So this is
Okay.
from electric charges, first chapter.
From
Hello?
where?
From
Electric?
first chapter,
Yeah,
electric
from where?
charges. First chapter.
Yes, yes.
So
Tell
what
me,
if
yes.
two,
What is your doubt?
sir? What if two objects of same, if they are identical? Hello,
No, no, I am not able to hear properly. Can you tell me again? Can you repeat?
sir. If two objects of same size and shape,
Mm-hmm.
if two objects of same size and shape are
Yeah,
rubbed
yeah. Two objects,
of same size and
size
shape
and
and
shape.
shape,
Mm-hmm. Rub.
rubbed against each
Yeah,
other,
rub. Yes.
rubbed
Uh-huh.
RUB. So what type of charge is exerted on each,
Yes.
is found on those two, and
Yes.
same material
So,
also, sir.
okay,
Material
what is your
also,
doubt?
sir. If
Yeah,
two,
material also same.
yes, sir.
Mm-hmm. So, what is the question? Last part I did not hear.
So what type of charge do they get electrified or not?
Okay. Do they get electrified or not?
Yes.
Oh, nice question actually. Mhm. So you have the same material, right?
Yes, same material.
You
Yes,
have
same
same
material.
material. Okay. Mhm. Okay, Kirtana, I'll just think over it and then I'll tell you. Maybe, are you there in the WhatsApp group?
Yes, sir. Yes, I'm there.
Are you there in the WhatsApp?
Yes,
Okay,
sir.
I'll
Yes.
answer over there. Okay,
Okay,
I'll
sir.
answer there. Okay,
That's fine.
yeah,
Okay.
a nice question. Okay, I'll answer over there.
Thank.
Yeah, yeah. Okay, are you people solving this? Somya? Somya, actually, I am not having. You can ask Guna madam. In fact, almost all the classes were recorded. So maybe you can get from them. You can get from them maybe. So you have to find out the flux through this surface. See, I can give you a simple clue. You think this surface as a like as one of the face of a cube. Cube of side B. Then what is the plus? Actually, in a board exam, this question may come in your board exam. Okay. Okay. Look, I'll just because we are running out of time. I'll just discuss this question. this is my phase. Okay, given phase here. Okay, now this has a distance d, right? This has distance d, this way also d. So at d by 2, that means exactly in the middle you have this charge q, middle of this q. Okay, you have charge q. Now I'll apply Gauss's law. Now I will apply Gauss's law. So Gauss's law says that flask, flask will be charge enclosed by epsilon naught. Okay, this is total flux actually, total flux. See, if I have a charge exactly inside the uh, cube, then flux will be through all the surfaces. From, like, it will, see, electric will go out through all the surfaces, right? Like this, like this, like this, like this, like this. Okay, all 6 surfaces, through all 6 surfaces it will go. So the total flux will be like this. So charge enclosed is only q. So this is the total flux. So I have to find out flux through only one surface. So you have to write flux 1/6, okay, of this q by epsilon naught. Okay, this will be q by 6 epsilon naught. Okay, do you understand? All of you understood this? Okay, nice. So I think Priyadarshini, I don't know whether you are trying to solve, because we are running out of time. I have just solved it, but there are many problems like this. Uh, so if you want to, like, you people have to solve your NCERT textbook first. Okay, all the exercise problem and these examples. Then you should go for competitive exam. And I think all of you people are interested in NEET and other things. So I'll just pick up few problems like this, advanced questions, so which we'll discuss. Okay, and the normal questions you might be doing all of them. If you have any doubt, you can post in WhatsApp group that this question, this chapter, this question number and all, or maybe any question, you can write it over your page, pen and paper, and then just click a photo and you can send in the WhatsApp group. If all of you are there in the WhatsApp group, then it is very easy to communicate uh, to all of you people together. Okay, it will be difficult to go with personal contact and all those things. Better be in the WhatsApp group. Okay, so with this today I will stop our class. Okay, if you have any doubt, you please ask me in WhatsApp group. Okay, see you on Wednesday again. uh, Bye.